Hi, so welcome to this lecture on testing, implementation, and documentation. So this is found under the implementation stage of the software development lifecycle. So we'll start off by looking at testing, then we'll look at our deployment, and we'll briefly talk of documentation. So when you're talking of testing a system, the first thing you need to come up with is a test plan. And your test plan should cover all the types and phases of testing, and it should guide the entire testing process and cover who, why, when, and what are the activities that are to be done. So your testing is basically looking at testing your functional requirements as well as your non-functional requirements based on your high-level design or your low-level design. So testing should be done before you even implement the system. So let's say the system has been developed or is being put in place. That's when you test it before you actually let users start using it. So you'll find that testing is found under the overall case of quality assurance activities. So quality assurance, we have things such as fault avoidance, fault tolerance, fault detection, debugging, usability testing, as well as our general testing. And in this video, we'll look at testing under unit tests, integration tests, as well as system tests. So how do you develop a test strategy? Firstly, you have to obtain a consensus on what are the test goals as well as the objectives from various stakeholders. Then you need to manage the expectations right from the start. But some people, during testing, they would expect you either to quickly fix issues maybe within a day or a few hours after discovering the issue, or they would expect you to find or to have certain requirements which were not agreed on initially. And then you also need to make sure that the tests are testing the right things so that we are heading in the direction, and you need to identify the types of tests that you need to work with. So let's look at unit testing. So unit testing is basically a testing technique in which individual modules are tested to determine if there are any issues. So with unit testing, you are looking at each individual module that makes up a system. So you find that a system can be made up of different modules or subsystems. Now you want to test each module. So let's say you've got a system that has got a web server, a web application, it has got an application logic, it has got some database logic. So you may want to test the web application logic module on its own, test the application logic module on its own, and test the database application module on their own, so that you can actually see what the problems could be with each module, so that you can actually correct them before you deploy the system. So unit testing is done by the developers, and the goal of unit testing is to confirm that our subsystems are correctly coded and they're doing exactly what is expected of them. So as you do your unit tests, you can either use static analysis or dynamic analysis. Under static analysis, you're basically looking at the code or the source code that has been programmed and checking if it actually is done right and is doing what is expected. So you can have a code walkthrough, a code inspection, or you can have some automated tools that you can use which can help you check for syntactic as well as semantic errors. Then you can also do dynamic analysis. Now box analysis will be covered by things like black box testing, where you're just testing the input and output behavior of the system. Here with black box testing, you just want to see if the system is performing the functionalities expected. You don't care how it does it, you just want to see if it's actually producing the required results based on the requirements given. Then there's white box testing. Now this one is also where you're now testing the internal logic of the system, and you're looking at the various modules at the source code and seeing how they're actually performing under the hood. Then you also have data structure testing. So under unit testing as well, you will do functional tests. So your functional tests are testing the functionality of the system, and these test cases are designed based on the requirements analysis document that was developed and the requirements that were found out to be the ones that the users want to be met. So with functional testing, you want to make sure that what you are meeting the requirements of the user on the system. And this functional testing technique is usually treated as a black box. We don't care about the code, we don't care about the implementation details, we just want to see if the system is meeting the requirements of our end users. Then we also do performance tests. So with performance tests, we want to see how the system is performing under different or varied conditions. And there are different types of performance tests. Some of the performance tests that you can do are, for example, stress testing. This is where you apply a load that is very big, which you think may strain the system, and see if the system can actually handle the workload that is of that size. There's also volume testing, where you can give it a lot of data and see if it can handle it. There's configuration tests to see things like how the various configurations between your software and the hardware are working. There are compatibility tests between various systems. Timing tests to see things such as response times, posting times, and processing times. Then you can also have security tests, environmental tests, and quality tests, just to see the reliability, maintainability, as well as availability of the system. And you can do recovery tests and how the system can also handle human errors to see if it actually has good functionalities to handle mistakes by users. Another type of test that you can do, so there's unit testing. Now there's also another type of test called user acceptance tests. So user acceptance tests are basically tests that are done to show that the system is ready for use by the users. And these tests are done by the users themselves. The developers are not involved here. The client decides how they want to test the system, and they're the ones who get the final output as well as the final report of the system. So when you're doing your user acceptance tests, you're basically looking for if the user accepts the system as it is in its current form. So you can do two types of tests. There's an alpha test, which is done at the developer's site or under the developer's conditions, and then you've got your beta test, which is done at the client site or at the actual deployment area, and you see if the system is actually doing well within the targeted environment. Then another form of test you have is system tests. So where unit tests are looking at testing individual modules, system testing is looking at testing the whole system and seeing if it's actually doing the work as required. So unit testing, we're just looking at individual modules. System testing, we're looking at the whole system and seeing if it's actually delivering the results that are required. This system testing is also taken as a black box testing technique. So the knowledge of your code is not required, but the satisfaction of the user requirements based on the requirements specification documents is what is being tested here. Then you have integration tests. So unit tests look at individual modules, but integration tests now look at how do you get two modules or two subsystems to communicate and work together. So with integration tests, we are looking at the interface between various modules of your software application, and the entire system is basically a collection of subsystems, and we want to make sure that these subsystems are integrated properly, they're communicating well, they're exchanging the right amount of data, and they're producing the right results required. So this kind of testing is done by the developers to test the interfaces among the subsystems. Then we also have structural tests. So structural testing is also known as white box testing or class box testing. So remember, we've got black box testing, which we have been using for our system testing as well as our unit testing, but we also have white box testing, which we use to check the actual source code. We want to look at the structure of the code to test it, to see how it does its operations. Because at times, the slowness of a system is not because there are few resources, but it's simply because the code is not well structured. So you want to see the various operations, how they are structured, which one is done first, if the code is well programmed, if there is reusability, modularity, and such factors. So these kind of tests require you to have knowledge of the code. So this one is done by the developers and is concerned with how the system does its work rather than the actual functionality of the system. So when you are now going through your tests, okay, this slide basically shows you the steps or the order in which you do your tests. The first test that you do is your unit test. You are testing each individual module. When you are happy with your modules, you then move to integration tests, where you are now testing the communication and the interfaces between those various modules as they create subsystems. Once you have tested all those integrations and you're happy with them, you bring together all the components and you come up with the final system and you do your system testing. So here you're testing the whole system as a black box test to see if it's actually meeting your requirements. When you're happy with the system itself, you then send the system to the user for user acceptance testing. And the user will evaluate the system on their own requirements. And if they're happy, we then move to the implementation phase. So under the implementation phase, this is where we are going to acquire our hardware and software. But you know what? The interesting thing about this is that we have already done this. We have basically acquired our hardware and software. We have done our software development and modification. We have come up with our database and we have trained our end users. Now we need to deploy our system. So when we are now deploying the system, we have different deployment strategies that we can use. But we're just going to focus on 4: the parallel, pilot, phased, and direct changeover strategies. So this can be called changeover strategies or deployment strategies. So you have got what is called the parallel changeover strategy. In the parallel changeover strategy, basically both systems, the old system and the new systems, run together at the same time. And then as they run together, you slowly decommission the old system, or after you're satisfied with how the new system is performed, you can do a complete cutoff of the old system. Then we also have the direct changeover strategy. So this one is where you, once the new system is ready for use, you have developed it and you now want to commission it, you cut off the old system immediately and start using the new one. Okay, so there's no room for you to first test both systems at the same time, and this usually occurs in environments where two systems cannot coexist. For example, I would like to believe some banking systems may not allow you to have two systems running at the same time, having the same kind of data. So you may need to do a direct cut over. Then you have the pilot changeover strategy. So this one is where your system is basically deployed in multiple locations, but not in all your locations of the business. So if you have got 10 branches, a pilot changeover strategy would have you deploy probably in 3 of those branches and then see how the system performs in those 3 branches. And then when you're satisfied with how the system is performing in those 3 branches, you can then cut over and roll it out to all the different locations in your system. So this one can allow you to, whilst you're using the pilot changeover strategy, you can actually also use the pilot and direct methods within the pilot changeover strategy. Then finally, we have the phased or the staged changeover strategy. So this one is an incremental approach where you deploy your system one module at a time. So if your system has got 10 modules, let's say it's sales, marketing, HR, IT, and etc., you first deploy the sales module, and then when you're happy with how it's functioning, you then deploy the marketing module, then you deploy the next module. So you deploy those modules one at a time or a few at a time until such a time when all the modules are finally all deployed within the environment. So you'll find that all these changeover strategies have got their advantages and disadvantages, and it's very key that you research on these advantages and disadvantages so that you're able to compare and contrast and decide which of all these methodologies is best for you. So thank you very much for listening to this lecture, and I hope you have learned a lot. Good day.